Okay, so this is number 13. So we like to minimize the x plus y. So the first thing is, we have the square roots, which is not really helpful. So let's square both sides. So that should give us x plus y plus 2 times square root of xy by the square of binomial. And that will be 1183. But at this point, as soon as I see this, the AMGM is just the first thing that comes into my mind. So AMGM is just like telling us when you take the two numbers, take the arithmetic mean, and this has to be larger than or equal to geometric mean of those numbers. And I multiply both sides by 2, so that should be x plus y, at least larger than the product of this. But it doesn't says if they are equal to each other, so we just need to kind of show it, and if this is possible. And this does work when you have positive values, but in this case we have integers, so which is a restriction. So maybe even we cannot really get that, but at least this does tell something. So based on this, we can say that x plus y is going to be larger than, oh, this is 2 times of this, which means this quantity and this quantity are close to each other, but this quantity a bit larger than this for sure. If they are equal, that's good, but we do not know that. But most of the time, this is larger than this quantity, meaning that if I divide both sides by 2, which is half of this number, so the x plus y should be larger than half of this number. So it's going to be like 5, that's 18, 9, 2.5 if I didn't do division wrong. So this is the number, but as you see, this is not answer at all. So we know that that is kind of eliminated without really knowing what two numbers work. So at this point, if you have nothing else, you can probably go with choosing one of these, but maybe you can start testing this number to see if there are two integers. But let's try something else as well. We got that one, that's good. But maybe instead of doing that as well, I'm gonna just do simplification with that number. So I can write this as this number 1183. I just want to test some divisibility. 2, 3, 5 doesn't work. 7. Let's try that 7. If I divide this by 7, so you get 1 time, so you got 4 left over, so 48, so 6 times 42, you got 63, which is 9 times. This is good because this is actually 13 square. So when you use square root of this x and then y, you end up getting this number, right? So, but this was on the radical. So if I simplify, that should be 13 root 7. Now we are kind of a bit better because, the x is integer, y is integer. So if they are somehow equal to this guy, then x and y both has to have this radical 7 somehow when you simplify. So which is why maybe I can convert this equal to a root 7, and then maybe this as b root 7, right? So that is 13 root 7. So from here, so a plus b has to be 13. So now we can just say, okay, this is equal to 13. So, and now we want to achieve the 2x and y that's close to each other, right? So then I can try, since this is a number that we are going to simplify, and then this is integer, so we take the square root. So this has to be integer part. This is the radical part. So then that would be integer. So I can try 6 and 7 because when they are close to each other, they are the product is largest. The sum is gonna be the minimum. So if that's the case, what we have, right? So we have 6 and 7 for those. So 6 root 7 and 7 root 7. And x would be, the square root of x would be 6 root 7. And then square root of y will be 7 root 7. If you square, so you got x equals 36 times 7. And then y would be 49 times 7. And that will be 7 times 3 is 21. That's 210. 7, 6 will be 42. And then 7, 4 is 28. So plus 63. So if you add 210 by this, you get 490. And then 60 plus this will be 100, so 105. So 105 plus 490, so 595, which is choice B. So which is possible as we see. So the goal is like as soon as we realize like the choice A is not possible, and then since we are dealing with integers, we just need to make somehow reasonable way to get like what is achievable. So and then that's what I tried right here. So when I try 6, 7, that gave me that one. And then if you are wondering, how do I know there is no